Hello everybody, welcome to today's Jakarta Tech Talk. We have joining us Edwin Derks and Josh Juneau presenting Jakarta EE and MicroProfile Key Features demo. Josh is an application developer, system analyst, and database administrator, as well as an author and Java champion. He's also a regular voice on the Java Pubhouse Off-Heap podcast. Edwin is a software architect, MicroProfile and Jakarta EE contributor, and a regular conference speaker I'm sure many of you know very well. At this point, I'm not going to take any more of their time. I'll turn it over to them as they have lots to discuss. So take it away, gentlemen.
Hello. Thank you for attending the conference today via Talks. It's great to have you here. I'll go ahead and open up the slideshow. Can you see my slides? Edwin?
Yes,
okay.
we can.
Perfect. So as mentioned by Hudson, this is the Jakarta EE and MicroProfile talk here, and we're going to give you some key feature demos here in this talk. It's me, of course, Josh Juneau and Edwin Derks, and you can see our Twitter handles there if you need to contact us. And so here's a little bit more about us. I'll go ahead and start. I am a member of the Chicago Java Users Group. I'm on the executive board. I'm an application developer, mostly targeting Jakarta EE and Java EE. I do database administration, primarily Oracle database. And of course, I do some writing and podcasting as well. And I work lots with the Apache NetBeans project. Java champions and the Jakarta EE ambassadors. I should have updated that slide. Sorry about that. Edwin?
Yes, I'm Edwin Derks. I'm a software architect / solution architect at Readiness in the Netherlands. We are an IT services and consultancy company, and I work mostly at projects at customers building Java-based solutions for all kinds of software solutions. I like to be active in the community, sharing my knowledge and gathering knowledge, often speaking and writing articles or blogs.
Excellent. So for today's agenda, we're basically going to just demonstrate some cool features of Jakarta EE9 and MicroProfile. And of course, during the session, if there's any questions, please feel free to ask them, and we will try and get back to you as soon as we can within the context of this conversation. And hopefully we'll just see those comments as they come in. But please do feel free. So we'll start off this presentation with a little bit about Jakarta EE9. And just wanted to make mention that this particular presentation will make use of Jakarta EE8 and MicroProfile 3.3. And the reason being is we're using Pyara server and or Pyara Micro in this case. And we want to be able to run both Jakarta EE8 and MicroProfile. So this makes it quite possible to do so. And in order to do so, you can get started by going to the GitHub site and downloading the demo that we have published. And all you have to do is incorporate the dependencies into your project. And then of course, the examples use Jakarta EE8. Now, just to mention about Jakarta EE9, it is not going to be backward compatible. It is not backward compatible, I should mention. It is already released, was released late last year. But Jakarta EE9 does have a namespace change. And so that's one of the biggest changes with Jakarta EE9 is that now, instead of pulling APIs into your code using the Java X namespace, you're going to need to use the Jakarta namespace. And so that's a little bit of a different, but primarily most of the features in Jakarta EE9 are very much the same as they are in Jakarta EE8. So everything you see in this talk is current and will work with Jakarta EE9 with respect to the way that the code functions. However, the namespace will be different if you opt to use Jakarta EE9. One more thing to mention is that Java SE11 support is available as of Jakarta EE 9.1. So it's not available at Jakarta EE9 out of the gate. So first, I would like to start off by talking a little bit about Jakarta CDI, Context and Dependency Injection. There have been some additions in Jakarta EE8. Actually, most of the additions, if you'll think of them as that, are new as of Java EE8. Okay, so Java EE8 was released by Oracle, and then that was then open sourced to the Eclipse Foundation under Jakarta EE. And so Jakarta EE8 really brings all of this under the open source umbrella. And most of the new features that are in these releases are from Java EE8. So many of the features you'll see me listing, they have been available since Java EE8, but there are a couple of differences. So the latest additions here for CDIs is modularization and support of Java SE, observer ordering, asynchronous events, configurators for major SPI elements, configure or veto observer methods, and apply interceptors on producers. So I wanted to talk just a little bit about some of the key features as mentioned at the top of the discussion here. So one of the things is the async process here in CDI. So in order to mark an event as asynchronous, you go ahead and just call upon the Beam Manager's fire async method, passing the event class. And so I'm going to go ahead and show you how that's done. So with our demo application here, I'm going to go ahead and show you the screen that you would see when you initially pull up the index page of the application. It's just a basic application that is going to display records in the database table. If you scroll down to the bottom here, you'll see that there's a form, and I can enter a new user here in this form. And so I'm just going to say user X, and the last name is Y. And then I'm going to enter age of 30, and then today is the date, and create this employee. And you're going to see that it successfully created the employee. And it has entered that row into the table. What you didn't see is that behind the scenes, there is an asynchronous CDI event occurring. And so let's go ahead and let's look at this code a little bit. So if I look at the form here, give me 1 second. You can see that I'm creating this employee, and when I click the button, it is going to call upon this create method, which is part of the Acme employee controller. And basically what this is doing is just taking the form contents and submitting it using REST. But in the process here, it creates this employee event, which has a payload. And this will go ahead and fire asynchronously because, as you saw, we call upon the fire async. And then what I can do here is I can say, when this is completed, it's going on behind the scenes. Nobody knows about it. It's a process that's running. When it's done, you can do something with it. If it encounters an issue, then you can go ahead and process it a different way. If you can look down here in the terminal, you can see that the new employee was created. So this event was fired, and it worked without an issue. If I scroll to the top of this class, you'll see that I did do the injection of this event right here. So you inject the event into your class, and then you can call upon it using the fire async. So next up, let's go ahead and look at some JSON binding. So this is a standard binding layer for converting Java objects to and from JSON. And so it easily allows you to serialize or deserialize objects to and from JSON, and allows for mapping of primitive types without doing anything extra, just there by default. And it serializes collections and maps as well. So this is giving you the ability to basically pass JSON to Java, and it will automatically convert it into a Java object. And you can also do the opposite direction as well. So this code that you're seeing here on screen shows you how to create a customer object from JSON here. So basically what you would do is get this JSON-B builder object, and it would create you a JSON-B object once you call upon the create method. And then from there, you would take this JSON-B object and invoke the from JSON, and we would pass this customer JSON text, which is just a string, and it would convert it into this customer class. You can see that it's just as easy as that. And let me show you how that's done here. So if I go back to this code in this example application, I've got this button at the top of my form here. And if I click create JSON, you see a bunch of JSON that is emitted to the screen here. Now what happens here in the code, if we want to look at this page again, I'm going to go down to the second tab where it says JSON examples, and then you see my button here, the command button. If I click, you can see in the code what I'm doing is I'm getting this JSON-B builder and calling upon create, and then what I'm passing is actually the items that are in that table above. See these employee items. That's exactly what it is. And then it's going to set the return message to the screen. So if I want to create JSON from a Java object, it's just a little bit different. You still use that JSON-B builder and you create a JSON-B object, but instead of calling upon the from JSON, we call to JSON, and we pass a Java object to that, and it will return us a string. So let me show you that real quick. In this case, I'm going to just copy and paste one of these JSON objects here. And I'm going to paste it into this text box I've got. And when I click this button, you're going to see a very minimal message here show up. It's just the name of the person that I've added. And if we look at the code, we're going to see that the action behind this button here does exactly as I had mentioned before. I'm going to create this new employee object, and then I'm going to go ahead and take this string, which was entered into the text box, and convert it from JSON to this employee object and populate this employee object. And basically, I'm just setting the first name and last name to the message to be displayed. So that's a little bit about JSON binding. So JSON processing is the ability to parse, transform, and query JSON data using an object model or streaming model. So this is done by using a JSON object builder, and this will allow you to build a JSON object. You call upon the create object builder method to create a JSON object builder, or you can call upon the create array builder method to create a JSON array. So one of the most interesting portions of JSON processing is the JSON pointer and JSON patch. So what JSON pointer allows one to do is to point to a particular element within a JSON structure. So you can basically indicate which element you would like to point to, and then this code will bring back that exact element and allow you to do what's called a patch. So we can replace a specified value in that JSON document with some other value, or we can transform it or edit it. And this will define only two data structures, objects and arrays, but it does define several different value types, which are mentioned there in the bottom. So let's show you how this is done. So if I take a look back here on this form, you can see that I want to insert search employee by address. This is a little bit misleading. It doesn't really do that. Basically, all of this JSON here that you see at the top, I can take one of those elements and I can basically replace it here using this patch. So let's say I want to replace element 1, and I want to replace it with test. So here is all of our objects returned, and you can see that the first element is actually been replaced with test. Excuse me. If I want to replace the first one, then it's actually a 0, right? Because we're talking about an array. So the first now element has been replaced with test. And actually, in real life, we probably want to replace this JSON with other JSON. So you could do that quite easily as well. Let me show you how this is done here in the code. So we take this JSON pointer form and I basically add the replacement string and the text into text boxes. And then what I can do here is call upon this find employee by last method. What I'm doing here is you can see that I use a JSON object to create a JSON object builder. And then what I do here is I'm calling upon this build employees JSON. And really what this is doing is just getting me a JSON array of all the employees in the database. Okay. And then I create this JSON pointer by calling upon the create pointer method and passing the text that was passed in. So my 0 or 1, this will create me in a pointer. And then what I can do is I can call upon the replace method of that pointer, and I can pass in the array that I want to replace the element of, and then I pass in the replacement string. So what I'm doing here is just basically saying, if there was no string mentioned, then just replace it with JSON expert. So if I didn't add any text in there, I would replace it with that. And then basically here, I'm just displaying the result. Okay, so Jakarta server faces, one of my favorites. I've always enjoyed using JSF for front ends for applications. And, lots of people nowadays are using frameworks that they think are better suitable for microservices and whatnot. But I want to argue that JSF is very suitable for microservice-based applications. And so I can show you a little bit about how I'm doing that here. Basically, the application that we have here for this demo is microservices-based. And so I'll show you how I've set this up with a JSF front end. But let's look at a little bit about another key feature first. It's local date time conversion. So if you remember way back in JSF 2.2 and whatnot, we had to transform dates in order to make them work with JSF. And they didn't work then with the local date time edition, which was new to Java 8. So in JSF, the newer versions 2.3, we are enabling the ability to utilize local date time. And let me see here if I can find right there. If you look at this column here, you can see what I'm doing is I'm converting the date time by passing in as a parameter here, this convert date time. I call upon the local date type and I pass it a pattern. That's all I've got to do is convert it, and I can now use safely local date time. So I can show you that the type of this date is a local date, okay? And basically that's what's being displayed on this screen here. These are using the local date time conversion. So let's talk a little bit about how am I getting this JSF front end to work with microservices. Basically, the way you do it is to use the view scoped controllers. So if I look at my form, it's just a basic JSF form. And the beauty of this is that I can utilize the many great libraries that are out there. PrimeFace is one of my favorites. And I can construct my my forms and my application using these great libraries that have been around for years. But this Acme employee controller is in the background here, right? This has got a business logic in it. And basically, I just make it view scoped. So every time the view is changed, every time you change screens, this is recreated. And then what I use is RESTful web services to populate the data. And I'll show you a little bit more about how I'm doing this here in a few minutes. But basically, you just call upon your methods and your data from this view scoped object, and it will work quite well. So let's show you that JAX-RS client now. One of the newer features of JAX-RS is the JAX-RS client. And like I said, this enables JSF view scope views to be used for interacting with remote web services to update the database. So what you see in the application here, excuse me, when you look here, is that this is not pulling directly from a database per se. What it's doing is using some RESTful web services to obtain that data, and then it's displaying that result. And so if I look at this employee controller, the initial thing I do is I construct this, this data set. And so the way I construct this data set, you can see what I'm going to do is populate this list of Acme employee items. And what I do is I call this URL, which is basically taking me to a RESTful web service, okay? And we use MicroProfile Config to get these different parameters here to construct this path. And Edwin will tell you a little bit more about that later. But the important thing to mention here is that I'm using this JAX-RS client. And what you do is you call upon this client builder and new client to obtain a client, and then I can pass it this path. And then what it's going to do is go ahead and return all of the items here in the employee database. So let me show you this service. So if you look here, I know it's kind of hard to see on my left-hand side over here, but if I'm looking in NetBeans, I've got this employee service. And basically what this is just a RESTful web service. And so I got this Acme employee class, which is a JPA class, which maps to my database. And then I've got this JAX-RS service set up. So when I call upon the Acme employee service, I can find by last and get the last name, or I can get all of the employees by calling find all. And this will query the database and return the results. And that's exactly what I'm doing in order to populate the table in this page. So RESTful web services have something called server-sent events. This is a new feature as well. It allows one-way communication channel, and it allows the server to send multiple messages over a single connection. The SSE event sync is used to stream messages, and SSE event is the base class. Outbound SSE event packages an event. So let me show you real quickly in our example here. We've got server sent events on this form. I've just got a quick button here that you can press. You don't see anything happen here on screen. But if we look back in the NetBeans console here, you can see that I've got a bunch of events being sent. So let's see what's going on here. So if I go back to my index page, and I just want to mention, when you download this code from GitHub, if you go to the index page of the employee client, that's where everything really kicks off. So you can see by reading that code, and just as I'm doing here in this demo, clicking on the different methods, it'll help you navigate around. So what's happening here when I click this button is I'm calling upon this controller class, which is a request scoped employee, SSE client class. And basically I'm creating this JAX-RS client, and I'm calling upon a service again. And this service is called SSE employees. And so what this is doing here is it's calling upon this employee service, which is right here. It's in the employee event project. So this service here is then going to create and initialize all the employees in a list again. And when I call upon this employee's service here, what it does is it passes in this SSE event sync context and the SSE context, as I had mentioned in the slide. And what this allows me to do is I can run this asynchronous process, which will send an event, and then it will receive, when I call upon the SSE new event builder, I can build an outbound SSE event and send it using the event sync. So it's not receiving anything, excuse me for misspeaking a second ago. But this will send. It allows me to send this outbound event. And then that's what you can see happening here in the background. So I could send as many events as I wanted to do from the server doing this technique. So let's talk a little bit about security. This is a feature that was added in Java EE, was much needed, and allows you the ability to apply across identity stores such as database, LDAP, embedded, uses annotations for ease of development. This remembers callers using cookies or the identity store. It allows group to role mapping so you can secure portions of your application using roles. It also enables standard expression language accessors and uses a simplified HTTP authentication mechanism interface. So let me quickly show you here what's happening with this code. So I've got a login page, and it allows me to accept a username and password, of course. And when I click the authenticate button, what this is going to do is it's going to pass a string-based username or password to this controller class, which again is request scoped. And at the beginning, the important thing to see here is that I'm passing in this security context object. I'm injecting that into the class, and then I can utilize that to perform my authentication. So what happens when I click submit is it goes ahead and runs this switch statement, which is going to call upon this continue authentication to obtain one of these case results. So continue authentication calls upon the security context to authenticate my request. All of this is doing is telling it to get this external request. And what it's going to do is obtain this request and return the response. And I'm setting up this authentication parameters object with the parameters. And I call upon this credential. And what I do is I am creating this username password credential with my username and password that were passed in. All this is doing, in short, is passing this to the server, authenticating it, and then returning a result. So the server handles all this. And then it will tell me if it's been a successful authentication or not. Very easy. And I would recommend looking more into this and to see in the Pyara console here, to get these security events set up correctly, you have to use realms. And so it could be happening in any type of compatible Java application server, Jakarta EE9 application server. But in Pyara here, this is probably needs to be re-authenticated. Basically, I set up these realms here, and it's the same way, like I said, in the other application servers. But this allows me to indicate if I want to use a certificate, or if I want to use a file base, or if I want to just set up username and passwords within the application server itself. And Jakarta Beam validation. This is a way which enables us to validate our fields. And so we can use annotations to easily validate the fields. Instead of going in and writing a bunch of if, else, and conditionals to determine if a field is going to contain data that qualifies to be entered into the database or not, we can just use annotations. Some new annotations, which are newer as of Java EE9, would be email, not empty, not blank, positive, positive or zero, negative, negative or zero, past or present, future or present. So I can easily annotate an email field and indicate if it's correctly going to contain that email or if it's got some just gibberish in that field. And then this allows me to better assume that my data is correct. Basically gives me better qualifications for my data. And then lastly, I wanted to mention Jakarta Persistence. This has got some updates in the last release as well. Allows us to use streams with JPA now. There is a ability to create repeatable annotations. Also, JPA works with the date time functionality. It was new as of Java 8, and it allows you to do CTI injection in attribute converters. Oh, I guess I have one more. WebSockets, excuse me. So WebSockets are a way to do full duplex communication between peers. You can create a WebSocket endpoint by annotating a regular POJO with server endpoint, and then you can create this message receiver method, which annotates with on message. And this supports opening messages or error messages or whatever may occur. And this makes it easy to create something like a chat client where you have a two-way communication, whereas a WebSocket is a one-way push, right, from the server. So WebSockets allow for that full duplex two-way communication. Okay, so at this point, I'm going to stop sharing my screen and I'm going to hand it over to Edwin. If anyone has any questions in the meantime, please feel free to ask them.
Yes, thank you, Josh. I was just answering a question regarding the next features for Jakarta MicroProfile. I have a slide on the end that kind of covers that, so briefly. But maybe in the meantime, you can
Sure.
tell something about it if you already would like.
Sure.
I'm starting my screen now. So, all right. So I'm going to cover a few key features of MicroProfile. As you have seen until now, Josh has been sharing Jakarta examples and key features, and MicroProfile complements on that by providing the real cloud-native capabilities. So Josh has also been demonstrating with running Payara on his local machine integrated in his IDE, but I will more focus on how the key features of MicroProfile can help you get your app ready, integrated into a cloud, in containers, in Kubernetes, if you like. The exact package that you need and why it is set up like that in your project to really get your app out as a cloud-native app. So that's kind of the context I wanted to share today. So I will start with one of the most important ones. That is MicroProfile Health. MicroProfile Health has been aligned with Kubernetes for a few versions now, and it provides the means like healthness probes that Kubernetes needs to determine if a specific app can be accessed for handling load. So we have two versions there. We have the liveness probes and the readiness probes. And the liveness probes tells Kubernetes, hey, this app is ready to put into the load balancer. And the readiness probe tells it, hey, it is now ready to receive traffic. So MicroProfile Health provides you as a developer the means to actually define and determine what makes your app live or ready. And the default is maybe usable, but maybe you have some specific needs that really tell your app now it is ready to receive traffic. And I will show that in the code now. So this is my locally running service, just the ones that Josh has shown. I'm just now accessing the health endpoints live at my local port, and it says that the service is up. So I can really reload this, and it's still up. But I'm accessing the live endpoint now, and this is the default. There's nothing really going on here. It just says default, my app is up. But I can also access the readiness endpoint. And this says a little bit more, because I have made my own version of the readiness health endpoint in the code. So this says, okay, it's now up because number of employees is 3. And what does it mean? Well, it queries if I can access the database and see how many employees are there. So this is where the 3 comes from. And how does it look in the code? That is like this. I have a MicroProfile Readiness annotation that comes from the specification, that I also can use, of course, the liveness version of this, but this is just CDI or HGB as we know it. It's a bean, but then annotated with readiness. I can implement the health check interface, and this provides me this method to implement that really I can determine as a developer what makes my app ready. So you can see here, I'm reading the number of MPs from the database and put that in the result that shows up in the JSON body for the health check endpoint. This is not necessarily the best thing to put into production, but what I really want to emphasize here is that you can really put anything you need to determine if your app is ready. So you have full control over this, which is really neat. The next one is MicroProfile Config, and that is a much desired feature for the Jakarta EE platform because it is available in MicroProfile, but it's not available yet in Jakarta itself. It has been around in Spring, for example, for a long time now, and due to MicroProfile in 2017, it made its way to the Jakarta ecosystem as well. And because we are running Pajar that implements both Jakarta and MicroProfile, you can mix and match the annotations in Jakarta, also benefiting from the MicroProfile config. So there's no barriers between these platforms that really cancels them out. They are complementary. So how does it look in the code? Like just already mentioned, we have this Acme employee config class, and we have 4 properties here. And these 3 are being injected from a properties file. This properties file is being shipped with the app. Nothing special, but it's just one of the locations MicroProfile Config looks for properties to inject in your code, like here. Also, just injection, CDI based, very straightforward use of this specification. But this one is not in the properties file. So where does it come from then? Well, this goes a little bit into the setup I have locally. I'm using Docker Compose, and via Docker Compose, I inject the property here via the environment variable. So when I run this app locally with Docker and Docker Compose, MicroProfile config picks up this value that is being injected here, and therefore can use it here in this field, along with all the ones that came from the properties file. So this gives you really the power to inject your app in a specific environment, like Kubernetes, for example, with the config maps that can contain your config properties, to make it more cloud native out of the box. So you don't necessarily have to locally install Kubernetes for that. You can just use Docker Compose and mimic running inside the cloud. I'm going to shut down this for a second for purposes later. So this is what you can do with MicroProfile Config. And MicroProfile 4.0 adds a ton of new features to this specification that you can use to even better integrate your config in certain environments that you want to put your app into, using profiles and environments that can distinguish itself from each other. Then there's also the MicroProfile REST client. And Josh has already shown the Jakarta REST client, the REST client that there is already available. You can use Java code to build up a HTTP call to another service. But with MicroProfile REST clients, you can do it as well. But here you can use a more annotation-based way of doing that, which more relies on convention and configuration than explicit code. So if you look at the code there, we can really see this. It's just a Java plain old interface, but I'm now registering it as a REST client from the specification. I can tie it to the bean, CDIO HTTP bean that it is going to be injected to. It consumes JSON. And this is actually the get method that's being executed when I call this find all method in the code. But this path is part of the URL. But this URL is not complete. I cannot just call this path and it will end up nowhere. So again, we are relying here on MicroProfile Config under the hood to provide you the URL for this for these calls. So this here is the convention on how you can define the base URL for the specific class Acme Employee Service Client I have just shown you there, the interface. So that means this is injected alongside with it passed on as a suffix that makes up the whole URL. And then I can inject this interface here in the code of the control that Josh has already shown. But now I can replace the existing JAX REST client for demonstration purposes with MicroProfile REST client by injecting here the REST client, the interface I just shown, commenting out the existing JAX REST client. And now I can fill the items list with this with the call to this method. And this is kind of neat because it abstracts away that there is a HTTP call being made, contrary to what you would do with JAX REST client. So you don't necessarily have to use MicroProfile REST client, but it can make your code easier to read because it is just Java what you read here now. So in order to demonstrate that it still works, I'm going to rebuild my app and start Docker Compose with all the services that are necessary to run the app. So in the meantime, this gives me a little bit of an opportunity to talk about how the Docker Compose is set up for this. Because my service can run and it can try to communicate with other services in a database, but it is easy if my service also has the dependencies available that it depends on in the same environment, because then I don't have to mock anything. I can just act that everything is live. And it's a real world example, but then local on my machine. So in this case, I'm starting a Derby database. We are using Flyway to initially fill some data, pre-fill the database. And after that, the three services, employee event, employee service, and employee client will be started, depending on the database and Flyway. So that means that the service I'm going to build can be tested locally, functionally, like it would be doing in an environment, fully fledged Kubernetes cloud, you name it. And by using Docker Compose here, that has a few advantages. And that's where the cloud native comes in. What you really want to do is test if your app works functionally, but also in a containerized environment, and ideally with Kubernetes. So having this setup, my app is being put into a Docker container, as I can show here in the Docker file. You can come back to this later, but we are using a Payara Docker file, and we are copying the app onto that. So that really makes it easy to put your app in a container and start it up. It's not easier, harder than that. And then with Docker Compose, everything will start up. So also this provides the ability to test everything locally, but not necessarily the scalability, because installing Docker locally can be a bit of a pain. And what do I really want to test here? That is if my app works functionally and not the scalability. I can do that on other environments or in the real cloud, but I'm not trying to mimic my local machine as being a complete cloud provider. That's that's hard to do. So Docker Compose really provides a midway to act like you're running your app in a cloud, but not actually doing so. So I see my app is back up. I can test if it's up, and also this one will be working as well. Then the last specification.
Sorry to interrupt. Quick question came in here from Alexander. He asks, if I want to migrate from Spring Boot to MicroProfile, what will be the greatest challenges for my team and him?
It's a different world. Ultimately, you will kind of have the same results because your service is exposing endpoints that can be communicated with HTTP, for example, or do messaging or whatever. So your app is kind of a black box for clients. So yeah, working with MicroProfile and Jakarta EE compared to Spring is a whole different world in building and deploying and operating the actual apps. Of course, there's a difference between the features Spring provides and which Jakarta EE provides and MicroProfile, but still, you cannot really compare them because they the vision is different. I actually will come back on that in one of the later slides. I will more go into detail with visual on why that is. So if you don't mind, I will continue with my talk, and then if the question isn't answered at the end, then we can revisit it.
Yeah, great. That sounds good.
Okay. So for now, the last specification I want to mention to get your app as cloud native as fast as possible is the MicroProfile fault tolerance. Because one good practice is to have your app upfront handle failure when communicating to other services, because that's likely to happen in, for example, a microservice environment. The chance that some service is slower or not responding or anything in a particular moment in time is kind of not big necessarily, but you have to act on it. So when you are building your service, when you are doing HTTP calls, it's often good to at least think about how many times should I retry this call when something happens, how long should it take, and what should happen with the fallback if failure occurs, because this will override the default behavior that you might get from Payara that might differ from all implementations, and will be more predictable for you to act on if failure occurs. And your service will also be more robust to maybe handle the failure itself. So this should ultimately help you or maybe even relieve you from looking into the dark or finding out which service is producing which error, because with these annotations, it can all become very easier to predict what will be happening when you actually put your service in a cloud native environment like Kubernetes. What you also can do is think about a circuit breaker and a bulkhead, but I won't recommend adding these front unless you have the data and telemetry available, because some services might not be just as scalable as your own microservices. They might fail when you put too many load on it. So you can use circuit breakers and bulkheads to relieve them of too much load. But these need a little bit more tuning according to the situation that actually is happening. Because if you limit the communication to the downstream services too much, then you are slowing down your whole system. But if you don't limit too much, you still have the possibility that you kick over the downstream services. So these should be used with more care than just the retry and all this I should just show. And when talking about cloud native, that's a lot of infrastructure comes there. I already have shown the Docker Compose file, but I have not really looked into the Docker file yet. And there's a reason why I have skipped over this part, the part where we download the database connector. And there's a reason for that. Because when we look at Spring, you usually put these components in your pom.xml with Maven, and then it kind of downloads the internet. Sometimes people jokingly say, but it tries to download all the dependencies and even transitive dependencies that are inside the dependency that you declared, and that compiles your app, and that might run. That's no problem. But you might also get in some dependencies that you don't expect or don't want. It might provide or contain some security issues, for example. That is not completely solvable with Jakarta EE. That's not what I'm trying to say. But using Docker files like this, what I'm now going to explain, gives you a more predictable way of handling your dependencies. Because the vision behind Jakarta EE and MicroProfile is that you have these specifications to compile against. The features, your business logic will be built with these specifications. But how it actually runs is completely separated from what you actually have built, because the app that you built ideally is very small, very thin, and doesn't contain any dependencies that should make it run. This can and should be put in the environment. And that's where this Docker file comes in. So if you look here at the front, this is the Payara 5/2027 JDK 11 Docker image. It contains Payara server. This is a box that says this is it. You are not dragging in other dependencies from the internet. This is just what you have. I will not, in this case, include my database driver in my app itself. I will put it in the infrastructure in my Docker image, meaning that I don't have this dependency in my Maven configuration. It is part of my infrastructure. And that makes it more predictable for me that I exactly have this dependency downloaded, put into the location where Payara can find it and put it on this class path, in addition to what it already has, of course, as an application server. But this relieves me from having to think about what I download from the internet when I compile my app. So from a security and maintainability perspective, this is more predictable and more reproducible and arguably even more maintainable than just compiling your code like Spring does and grabbing everything from the internet, which may seem fine, but under the hood, it may not necessarily be fine. And that is the key point what I want to make here. The Jakarta EE is more than just the code. The whole package can provide more benefits than just the features that the specification provides. Having that said, the time is almost up, so I will finish up here. Looking forward, Jakarta 9.1 is not around the corner, but we are working hard to get it out the door, and that will support Java 11 across a platform. There are a lot of application servers like Payara that already support Java 11. You can build your app with Java 11 and run it there, but platform-wide, there are some things to fix to make it Java 11 work everywhere. And also, MicroProfile 4.0 has been released at the end of last year, and we are now seeing the implementations coming, like Payara is coming with the implementation of MicroProfile 4.0, which has a lot of new features compared to 3.3, which almost took a year to really get out the door. So maybe in the next session about MicroProfile 4.0, you can really see the features running there. And if you are interested in the meantime, you can of course look at specifications of what features you can expect. So this will wrap up our demo session. I hope you learned something and you have been inspired to use Jakarta for your own projects. If there are any questions, of course, ask us now or after the session. Also, we are very active on Twitter, so don't hesitate to contact us. We are always happy to share information and get to know you guys. Thanks.
Indeed. Thank you.
Awesome. Well, thank you, Josh, and thank you, Edwin, for that presentation. That was great. We do have a few more minutes here. If anyone has any last-minute questions, feel free to ask them in the chat or in the Ask a Question tab, and we can ask them. But just a few housekeeping matters here before we wrap up. Our next Jakarta Tech Talk is going to be happening on March 8th. That will be presented by Karina Varela and Otavio Santana. And the topic will be architecting and delivering Java applications in the cloud era. If you're interested in attending that, I will post the link to that session in the chat here. We are also always looking for more tech talks to present. So if you're working on a cloud native Java project and you want to share it with the community, by all means, you can sign up to present using this link here in the chat. And of course, we also appreciate any feedback you have for us. So if you wouldn't mind completing the survey post-event by clicking the green button below the video window to let us know how you enjoyed the session and anything we can do better, we would be thrilled to receive that. So thank you, everybody. At this point, I'm not seeing any more questions, so we will wrap it up. Any final words from either of you before we go?
Stay tuned for Jakarta EE9.1, which will be released in the next couple of months, I imagine. And go to the GitHub site to download this project and get started.
Yes, and get involved if you like. It's an open source project, and we welcome involvement very much.
Awesome. Well, thank you both, and enjoy the rest of your day, everybody.
Thank you.